Alright, so just a heads up, we're going to finish our last section today. We started it yesterday talking about factoring techniques. I think yesterday went fairly well for us, just refreshing our memory on some of those. When we come back on Tuesday, okay, we will be having our review day for this unit because this is the last section, which means your unit tests will be on Wednesday. Okay, I gave you a heads up the other day. Okay, I'm doing it again now. Also, because the unit test is on Wednesday, that's when I will be collecting all of the homework from the unit. Okay, so make sure all the work that you have are on those pages. If you used any extra paper, include that as well. You're going to eventually take out just the homework pages from the unit and staple them together. Okay, make sure your name's on it. And then after I'm done looking over all that, I'll hand it back to you. Okay? Alright, so yesterday we were taking a look at some different factoring techniques. Can we rattle off maybe some of the names that we discussed yesterday? Different ways we can factor, go ahead, Sarah. GCF, when we pull out the largest number or the largest or the most variables out of every single term. Okay, that's one type of factoring, yeah. Grouping, or remember the other one I showed you yesterday? Go ahead, Dylan. Divide and slide. Okay, so that method is when you have an A term, the number in front of the x squared, that's something other than 1. Okay, you have to be confident with either grouping or divide and slide. Okay? Another one, yeah. Difference of squares, right? If we have some perfect squares going on and they are being subtracted, meaning difference, we could use that technique. And then our last one, go Rebecca. Trinomial. The trinomial, I refer to it as the I am format because that starts with the coefficient of 1. Okay, so we have 4 techniques. We went through all those yesterday. We're going to take a look today on the calculator how we can use the graphing capabilities to help us solve an equation. So on page 20, we did the top 2 yesterday. When we solved these equations, we got x equals something, and I think we got 2 numbers for both of those. Is that correct? Okay. So what we're going to try to explore today is, what if we tried to solve this one? What do you guys feel like doing first? Anything for the office this morning? No? We're good? Good morning. I don't think we have anything today. Thank you. Have a good day. Happy Friday. Okay. How might you guys want to tackle this one? Is there something we got to do first? Yeah. Alright, we want it equal to 0. That way, if we were to try one of those factoring techniques we just mentioned, we would be able to break apart or separate those factors. Okay, so we need it equal to 0. Now, when you take a look at that, what are some factoring techniques that you might want to try? Is there GCF? Yeah. Just a negative, right? Because there isn't really a number that can go into all of those. So if you wanted to take out a negative, you could. It definitely doesn't fit, bless you, it definitely doesn't fit the I am profile, right? Okay? It's not a difference of squares. And I don't know about you, but if I were to try either the grouping or the divide and slide, that involves taking the A number times the C number. And I don't want to do 2 times, or negative 2 times a negative 157. That would be a very large number to work with, right? So what we're going to do today is discuss, well, what if factoring doesn't work, or what if the numbers are so large that you don't feel like factoring? Okay, so let's think about this. What if you can't factor, or the numbers are so large you just don't feel like it? Not that you're lazy, you just want to go about it in a more efficient way. Do we know another way we can solve this quadratic equation besides using a factoring technique? What do you think, Rebecca?
Use like a formula square root of negative. I actually forget it.
That's okay. A lot of people do. Yep, you're on the right track. So what's that formula you think she's referring to? What's it called? And then do we remember the formula itself, the format? Go ahead, Tori. The quadratic formula. Okay, so if you can't factor or you don't feel like factoring, try the quadratic formula. Right? So what is that? It's a beast. There's a square root going on. Do we remember it? I'm sure once we write it down, we're like, oh yeah, that was it. Yeah.
I know like the bottom portion of it.
Okay.
2AC.
It's just 2a.
Oh yeah, that's right.
AC is up top. Yeah.
Okay. Something equals positive, negative, the square root of numbers plus 4.
A little bit of everything. Good, Rachel?
Isn't it plus or minus b? Or
There is a plus or minus in it. And there is a b in it.
b plus or minus the square root of b minus 4ac? Was that it?
There, you're close. Ashlyn?
It's the opposite of b.
The opposite of b. Plus or minus the square root of, yeah?
Well, b squared.
B squared minus 4ac. All of that over 2a. Do we know what this quadratic formula equals? Rachel said it was like something equals, but what is this? You know what this something is? It is x, okay? So in the top two examples, we solved for x using the factors, but if factoring isn't possible, or you don't feel like doing it, you can solve for x using the quadratic formula. Okay, so it's x equals. Has anyone ever sang you the quadratic formula song? Do we want to hear? Oh, you know it? You've heard it?
Yeah, I've heard it before.
Do you want to give it a shot?
I don't.
You don't.
I
Neither,
just know they made it in a song.
they made it. I don't want to give it a shot either, but I'm probably going to end up singing it to you guys anyway. Okay. Do we know Pop Goes the Weasel? Bum ba dum ba da 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 da. That? Okay. I don't sing, so please don't judge. Okay. If you do, I really don't care anyway. The opposite of b plus or minus the square root of b squared minus 4a and c all over 2a. Okay? Quadratic formula song. Deal. Alright, so we said that we could try GCF on that, but we really could only pull out a negative. Okay, that's not really that significant. IM didn't work, difference of squares didn't work, and I don't feel like doing divide and slide or grouping because the numbers are just so big. So let's go ahead and try the quadratic formula. X equals the opposite of b. So based on our quadratic equation, what would the opposite of b look like? Good, Rebecca? Negative 36. All right, plus or minus the square root. All right, this is where a calculator might come useful. We need b squared. So we need 36 squared. Can someone help us out with that? Yeah.
1,296.
1,296 minus, and then we need 4 times a, which is negative 2, times c, which is negative 157. So we're going to do 4 times negative 2 times negative 157. 1,256? Sound about right? Right? All over 2a, so 2 times negative 2, which would be negative 4. Alright, let's go ahead and clean this up a bit. We can maybe subtract the numbers inside of the square root. 1296 minus 1256, so that's pretty nice. That's 40 all over negative 4. Is the square root of 40 a nice whole number? No. Okay, so that means that our x solutions are going to end up being some decimals, and like forever decimals, not like 0.25 decimal. Okay, lots of numbers. So I want to go ahead and we're going to convert this fraction into what the two decimal values for x would be. Okay, so on your calculator, we need negative 36. And then maybe we'll do the plus, because there's a plus or minus. You do have to do both. We'll do negative 36 plus the square root of 40. All right. Now on your calculator, you have to hit enter, because that represents the entire numerator part of your fraction. And then we're going to take this answer divided by negative 4. So our first x solution we'll say is 7.418419, however you want to round it. But we are going to get a second answer as well if we did negative 36 minus the square root of 40. Hit enter and divide by negative 4. 10.581. Can we get those numbers? You doing okay? All right. So in terms of an equation, okay, we can use the quadratic formula to help us solve these quadratics. But what about in terms of a graph? Okay, if we were to graph this quadratic equation, which is a more specific form of what's referred to as a polynomial, this is a quadratic, right? So it should look like a U, a parabola. Which way is the U facing? Can we determine that? Yeah. How'd you know down? Yeah. The A value is negative. All right, so I should be able to draw on here an upside down parabola, but the question is, how do I know where to draw it? Do I draw it very large? Is it only showing up on the left-hand side? Is it only showing up on the right-hand side? How do you think we can use these two answers for x we found using the quadratic formula to help us determine where the graph is located? Do you know what these two numbers mean? What do you think, Rebecca?
They're like, kind of like where you would hit the x-axis.
They are your x-intercepts. Okay, remember we said in terms of intercepts, an x-intercept is when the y value is 0, right? And in our equation, isn't it equal to 0? Wouldn't the y variable technically be over here in that case? Okay, so notice how when the y value is 0, your x solutions are representing x-intercepts. So what we could do is perhaps guess we have one intercept over here, maybe at that 7.419 spot, and we have another one over here at the 10.5-ish spot. Okay, I'm just guessing. This is a rough sketch. So if the two x-intercepts are found over here and it's upside down, our graph probably looks something like that. Does that make sense? Okay, that's what these two numbers from the quadratic formula mean. Those are your x-intercepts in terms of the graph. Okay. Now what your calculator can do is find these x-intercepts for you. So I want to go over how you can do that. Now the first thing we have to do is get a picture of our graph. So where do we go on our calculator to graph an equation? Remember the buttons good, Emily? Y equals, if you have anything in there, go ahead and clear it out. And we're going to type in our equation, negative 2x squared plus 36x minus 157. All right. Now before we hit graph, we have to make sure that we can see the spots that we want to see. Okay, we have to change our window, bless you, And we're interested in seeing the x-intercepts. Now, we already know where they are, so that helps us out. But let's try to pretend we didn't know where they were, okay? So we're not sure if they're negative or positive. So in terms of your x values, let's choose a negative number and a positive number. Maybe we'll start with negative 10 and positive 10. Counting by ones, I think that'll be okay. Okay, we're pretending that we don't know where these x-intercepts are. What about the y value? X-intercepts have a y value of 0, so we have to make sure that 0 is in between the lowest and the highest. So in this case, we're going to want to choose a negative number for the y min, but also a positive number for the y max. So if you guys want to choose negative 10 and positive 10 again, that's okay. We can always go back and change these. This is just a beginning spot. Okay? So go ahead and hit graph. Alright, so there's our upside down parabola like we anticipated, right? And we can clearly see one x-intercept, but based off the curvature, we could probably anticipate one over here, right? Okay. Also notice that we have all of this empty space on the left-hand side, so we could probably clear that out if we wanted to. Yeah? Nothing's on yours?
It's just a straight line.
Can we get that? Is that okay? All right, so let's go ahead and clean up our window a little bit based off of what we have here. We clearly don't have to go all the way out to negative 10, but we do have to go further than positive 10 to see that other x-intercept. So for instead of negative 10 for the y min, maybe you want to do 0. Okay, we'll cut off all that empty space. We got to go a little bit more than positive 10 on the x-axis, so maybe we'll do 15. Okay? Notice how that cut off all the space on the left, and we can clearly see the other x-intercept. Okay? So I would try to start with the negative 10s and positive 10s just as a beginning ground, and you can always go back and play around with it from there. Okay? Now, on your calculator, we're going to let the calculator find these points exactly for us. And do you remember where we found like the intersection and the max and mins? Good, Marie? Not Marie. Maddie, sorry. Yes, okay, notice how calc is blue, so you have to hit the blue button first. So before we chose, or we were using options 3, 4, and 5. Can you maybe scroll through that menu? I mean, there's only 7 of them. Can you pick one that might represent or mean x-intercept? What do you think, Rebecca? 0. Okay. So here's what's a little different on your calculator. Your calculator might use different terminology. You're used to hearing x-intercept, but what's it called? A synonym? A similar word, right? A similar word for x-intercept is 0. You might also hear the word root. Because if you were to think about a tree, the x-intercept is acting like the ground, and your roots start at ground level. Okay? So x-intercept, 0, and root, they all mean the same thing. Okay? It's just a different word to represent the same idea. So we're going to go ahead and select option 2 for 0. And what's nice about this is it works the exact same way as the high point and low point. Remember how we had to pick a point on the left, a point on the right and do your guess, we're going to do the same thing here. So we're going to move that little spider to where we think that x-intercept is, okay, as close as you can get it. And we're going to, first question is asking us to pick a few points or go to the left a little bit. So go ahead and hit the left arrow or left button a few times. You can hit enter. It then wants you to pick a point to the right of where you think it is. So hit the right arrow a few times. Do you see those two arrows popping up again? Just like maxes and mins, you're telling the calculator it's somewhere in here. Okay, so the last question is a guess. And go ahead and hit enter. So with that word 0 on the screen, that's the exact x-intercept. And notice how it makes sense, right? Because it's telling you the y value is 0. So based off the calculator, we get 7.419. And that was one of our solutions from the quadratic formula, wasn't it? When we did it by hand? Okay. Let's go through the same process for the other x-intercept. We're going to hit second calc to go back to that menu to select 0. This time we have to scroll over to the other side. Okay. Once you kind of think you know where it is, we're going to move to the left a little bit and hit enter. Move to the right a little bit, hit enter, and take your guess. We get 10.581. The same exact answer from the quadratic formula. Okay? So we can find these x solutions when factoring isn't possible, or you don't feel like using the large numbers. You can either do it by hand using the quadratic formula, or if you do have a graphing calculator, you could let the calculator find those x solutions for you. Okay? However, if factoring is nice, we're going to try to do that like we did up top yesterday. Okay? We doing okay with the calculator this time? Alright. So that's the end of the section. We still have a good solid 25 minutes. I want you to work on some of the homework problems. Okay? Practice your factoring, try some of the calculator ones, get used to the buttons, see how you do. Yes, ma'am? You do? I'll be over in a second, okay? Rachel, or not Rachel, Rebecca, did you have a question? You're stretching? Okay.